Hello, this is Mrs. Bentley, and I'm here to go over graphing quadratic equations. So if you look, we have our 5 steps we are going to follow. Step 1 says write the equation of the axis of symmetry using the equation x equals the opposite of b over 2a. So when we graph equations, instead of the equation being in the form of ax squared plus bx plus c equals 0, we change the 0 to a y equals. So if you think back to when we graphed linear functions, we always wanted our equations written in slope-intercept form, y equals mx plus b. Well, when we solve quadratic equations by graphing, we always write the equation in the form of y equals ax squared plus bx plus c. Now, if you look at number 1, they want us to graph y equals x squared plus 2x minus 3. The first thing we're going to do is identify the a value and the b value. Okay, so a equals 1, b equals 2, and if you notice in the axis of symmetry formula, it is not necessary that we identify the value of c. To find the axis of symmetry, you're always going to say x equals the opposite of b, so that's going to be negative 2, over 2 times a. So 2 times 1 is 2. If we simplify this equation, this is going to simplify to the equation x equals negative 1. So over here on the left, you're going to write the axis of symmetry, x equals negative 1. Now, if you think back to Math 1, when we graphed lines, the equation x equals negative 1 is going to be a vertical line. It intersects the x-axis at negative 1. So we're going to go ahead and sketch this axis of symmetry on our graph. We're also always going to use the number that's in our axis of symmetry as our central point in our table of values. So in our xy table, go ahead and place negative 1 in that bold middle rectangle on the table. Now, once you have your axis of symmetry point, you need to select 2 numbers that's less than negative 1. So we could use negative 2 and negative 3, and then 2 numbers larger than negative 1. So we could use 0 and positive 1. We have a couple options here. We could individually go through and substitute the values of x into the equation, y equals x squared plus 2x minus 3, and get our output, which would be our y coordinate. Or we can use our graphing calculator to look at the table of values. Okay, so on your graphing calculators, follow the steps with me. We're going to go to y equals and we're going to type in the equation x squared plus 2x minus 3. And now to get to your table of values, notice the word table, I'm pointing to it, is above the word graph. So you're going to have to hit your second graph key, and that's going to give us the list of our table of values. Now, if you look back at our table, we started our table at negative 2. So when x is negative 2, y is negative 3. When x is negative 1, y is negative 4. When x is 0, y is negative 3. And when x is 1, y is 0. Actually, we started our table at negative 3. So you're going to want to use those first 5 values that I have showing in my table. So remember, on your graphing calculators, when the table comes up, you may have to scroll up to get into those negative x values. So the y table, we should fill in 0, negative 3, negative 4, negative 3, and 0. If you fill your table incorrectly, you should see the symmetry. Notice right here at the negative 1, we have negative 4. And this is going to be our vertex point. Around our vertex point, you're going to see this symmetry form. We have a negative 3 and a negative 3 and a 0, 0. That's going to give us that U-shaped graph when we go over and plot the points. So let's do that now. So we're going to go left 3 and stay on the x-axis. We're going to go left 2 and down 3. We're going to go left 1 and down 4. And notice this point lies on that axis of symmetry. Your vertex should always intersect with the line that we've drawn as our axis of symmetry. We're going to go 0, -3. So this is your y-intercept. And we're going to go to the right 1 and stay at 0. Now you're going to sketch the parabola. Remember, the function is going to continue to increase, so we're going to indicate that by showing those arrows. So this is the graph of this quadratic. Now we have some things to answer. It says, does this parabola open up or down? This parabola opens up. The vertex is always the turning point. This is your vertex for this function. So notice that the vertex is at the bottom of the graph. We call this a minimum. Okay, so this time our vertex is a minimum value of the function. So we're going to circle minimum. We have our axis of symmetry. We're going to label the ordered pair the vertex is located at. So that's -1, -4. And it doesn't ask for the roots, but we're going to go ahead and state those roots because step 5 does say locate the roots or the zeros. And we're reminding you that those are your x-intercepts. So here is one root. And here is another root. So this quadratic equation does have 2 roots or 2 solutions. So we would say that our roots are located at -3 and +1. Okay, we're going to take a look at number 2. So again, make sure the equation is in standard form. Y equals ax squared plus bx plus c. And this one is. So I'm going to identify my a value equals -1, my b value equals -4, and we're going to use that axis of symmetry equation, x equals the opposite of b divided by 2 times a. So the opposite of -4 is +4, and we're going to multiply 2 times -1, so that's -2, and 4 divided by -2 equals -2. So our axis of symmetry is the equation x equals -2. Remember, we're going to make that our central x coordinate in our table. We're going to select 2 numbers less than -2, so -3 and -4. And then we're going to select 2 numbers greater than -2, so -1 and 0. Okay, we're going to jump over to our graphing calculators. Okay, so you should be on your graphing calculator. Go ahead and hit that y equals key. We're going to type in the new equation. We have -x squared minus 4x minus 4. And once you have the equation typed in correctly, hit second graph, and you will be able to scroll up to where our table begins at -4. So we are going to write down the values -4, -1, 0, -1, and -4 in the table under y. Okay, we're going to draw the graph. Let's make sure we also graph the axis of symmetry. So remember, our axis of symmetry is that line x equals -2. So come over to -2 on the x-axis. We're just going to use a dotted vertical line passing through -2. We're going to now plot those points from our table of values. So we're going to go left 4 and down 4. And left 3, down 1. -2, 0. So this is our vertex point. -1, -1, and 0, -4. So notice this time our parabola is flipped. It's opening downward. And remember, the parabola is going to continue decreasing to -infinity. So make sure you put the arrows on the end indicating this parabola will continue to decrease. So this time we're going to state that the parabola opens downward. When it opens downward, notice your vertex is now at the top of the parabola. So we refer to the vertex as a maximum value of the function. So we're going to come over and circle max. And our vertex is located at the ordered pair -2, 0. Okay, in addition to that, we're going to try to find the roots. You'll actually see that this time we only have one solution. Notice this parabola only intersects this x-axis one time. That means we only have one root, and that root is located at -1, -2. So our solution to this function is just -2. Okay, if you flip over, or actually right next to this, you're going to see, or on the back, you're going to see questions 3 and 4 for you to try on your own. So go ahead and practice those, and we will go over these on Monday. Thank you, and this has been Mrs. Bentley on graphing quadratic functions.